Next concept that I want to tell you about is the idea of packets and packet switching. And I kind of hinted at this. On the internet, the most basic notion is not of an entire connection. I think of connecting to some server and it sending some data there and it sending me back some data. But that's not actually how things are structured in terms of the routers and the internet. Things are structured not in terms of connections, but in terms of packets. If you want to send a message, you send that by sending one or more packets. You might have to break down a long message into multiple packets. So each packet is a certain amount of data. There's some maximum on the length of a packet, like maximum packet size might be 1,500 bytes of data, for instance. The sender breaks up the message that's to be sent into a bunch of packets. By the way, not packages, they're packets. And the recipient puts them back together again and figures and uses that to reconstruct the message that the sender was trying to see. So the router, in the application view, the application thinks it's just sending long messages, like downloading an entire file. From the router's perspective, the router doesn't have any knowledge of that. The router just sees packets, individual packets, one at a time. So the networking code that's in your operating system is responsible for translating between those two views, taking that long file download that Google Drive is trying to send you and breaking those up into packets to send over the network. Let's talk about reliability and what guarantees you get from the network. Stuff happens. Data can get corrupted while it's in transit on the network. Errors can happen. And so what the internet strives to provide is a notion that if random errors happen to the packet while it's in transit, then they'll be almost certainly detected, and then the packet can be ignored, thrown away. We call it dropped. If there's some error, if there was some error was introduced in the data while it was in transit. Okay? If you want some intuition for why this could happen, imagine that you're using Wi-Fi, and your laptop sends a packet over Wi-Fi. That's over a radio. Someone turns on their microwave oven at just the wrong time. Maybe that interferes, and some of the bits aren't received correctly, and there's some random error that happens. Okay, so the protocols provide some mechanism to try to detect those kinds of random errors. And then if an error happens, then the packet is just lost. So there's no guarantee. If you send a packet through the network, there's no guarantee it'll actually get there. This is called like best effort, or maybe it'll get there, maybe not. And they could be dropped. And it's not just a corrupting of the data, but it can be that if routers get overloaded, they might just decide, sorry, not forwarding your packet for you. I got too much to do. Sucks to be you. So your application is going to have to be designed. The higher level layers have to be designed so that they can manage that, so that they can deal with that. Okay? And I should mention that there's no crypto built into the basic internet. So for instance, if there's an adversary present somewhere maliciously modifying packets, not just randomly changing some bits at random, then that probably won't be detected by the basic mechanisms. So there's a checksum, but that's not a cryptographic checksum. And an attacker can introduce malicious changes. And if you want to try to detect that, if you're worried about an adversary, you will need some higher level mechanism to deal with that. It's not built into the basic internet protocol. Yes? The difference between a cryptographic checksum. So by cryptographic checksum, it would mean something like a message authentication code, a MAC, which we've just taught you. And a MAC, you have the guarantee that if the adversary doesn't have the secret key, any modification they make will be detected by the recipient, right? An ordinary checksum, a non-cryptographic checksum, does not have that property. Ordinary checksums are designed to be likely to detect random errors. But the way they're designed, it's usually easy to make a targeted modification, find a deliberate modification that won't be detected. So like an example of a super, super simple checksum, it's not, you wouldn't actually use, but just to give you some intuition of a non-cryptographic checksum might be take the sum of all the bytes in the packet. Your credit card numbers have a checksum digit. And it's not quite right, but it's something like that checksum digit is like the sum mod 9 of all the other digits. Okay? So that means that if one digit is kind of, you type in a digit wrong, it's likely that the checksum won't match and then it'll be detectable. But if you were making deliberate modifications, you could change the digits in a way that the checksum will come out correct. That's how a non-cryptographic checksum works.